Linked list. Introduction. Linked list is a data structure which is used to store the data in sequential manner. Linked list is dynamic memory data structure, where we have to provide data part and address part of next node. Linked list is divided into one of the further subtype. Singly linked list. Singly linked list contains nodes where each node contains data and link to the next node. Creation of linked list. To create a singly linked list we need to use structure consist of data part and link part. Here we are using integer as a data type and integer pointer to store the address of next link. Struct node. Int data. Struct node asterisk link. As struct node is a data type that we have defined, so we are using pointer to it. Now let's check main function. Declare struct node asterisk new node to make a new node, and a head pointer which will be initialized to 0. Use another temp pointer as well. New node data is equals to 0. New node equals to typecasting to struct node malloc size of struct node. Take input using scanf function. To store the data use ampersand new node arrow data. Check whether head is equals to 0. If it then head equals to new node temp equals to head. Else, temp arrow next equals to new node. Temp equals to temp arrow next. Use while loop until user ends creation of nodes. Insertion. Insertion at beginning. For insertion at beginning, create a new node. Take data inside new node using scanf %d ampersand new node arrow next. As head pointer contains address of first node, we have to change the content of head node to new node, and also we have to make a link from new node to the first node before inserting. New node arrow next equals to head. Head equals to new node. Insertion at end. For insertion at end, create a new node. Take data. So here we have to store null at new node link part and also have to update the last node's address, which will contain address of new node now. Use temp pointer to access to the last node. While temp arrow is not equal to null run loop. Temp equals to temp arrow next. Then temp arrow next equals to new node. So the last node will be new node. Insertion at specific position. To insert at specific position, we have to traverse the linked list up to the last node of position. That is position -1. To traverse, we will use a for loop from I is equal to 1 to I is less than an incrementing value of I by 1 each time. So now temp is at its position. All set for make changes. Temp is equals to temp arrow next. In order to store next link at link part of new node. New node arrow next is equals to temp arrow next. temp arrow next is equals to new node. Deletion of a node. Delete from beginning. To delete from beginning, we have to use temp pointer of data type of struct node. Temp is equals to head. Then head is equals to head arrow next. So head will contain address of second node. Now we can delete the first node by free temp. So now first node of actual linked list is deleted. Delete from end. To delete a node from end of linked list, we need to traverse up to second last node and need another pointer to traverse up to last node. So we have to modify the address of second last node. Declare an initialize temp pointer to the head, and declare another pointer as temp1, while temp arrow next is not equals to null. We will run the loop. Temp1 is equals to temp, and temp equals to temp arrow next. After completion of loop, we will store null at second last node, and free the last node. Temp1 arrow next equals to null, and free temp.